Let's take a look at applying the concept of a unit vector to finding a velocity in a given direction. So imagine the following situation, that this is my x-axis over here, and then imagine this is my y-axis over here, and within here I'm going to have a unit vector. So to make things work out just so, every 5 spaces will be counted as a 1. So let me see here. For example, this would be 1, okay, so this would be a 1. 5 spaces, another 5 spaces too. I have to be really careful here so I don't miss anything. This would be a 3, this would be a 4, and say this would be a 5. Let's also repeat this along the vertical dimension. Let me zoom in. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Yeah, let's maybe do one more. 1, 2, 3, 4, 5. There we are. So this is our coordinate system, and now imagine that within this coordinate system, as an example of what's possible, we have a vector. And imagine that the vector begins here, and let me see here, it goes up to the point 5, 4. And I have to be just so perfect here. So let's first emphasize the components of the vectors. Those are the shadows that basically it casts onto the x and the y axes. So for example, like this here, that represents, as you can see, the horizontal component of the vector, and then this represents the vertical component. Let's repeat these. So for example, from here to here, this is the shadow onto the x-axis. And then here, this would be the shadow onto the y-axis. Let's write the coordinates. So this is right here, the coordinate 1, 1. And these coordinates are 5, 4. Now it's possible that you can find the components simply by looking, right? This, if you count it, that's 4. So this is 4 this way. And then here, if you count this in the vertical dimension, as you can see, is 3. Which means, by the basic Pythagorean theorem, that this is 5 as the length of the vector. Just as a reminder, if you wanted to, let's call this the vector v. I could find it by using the Pythagorean theorem, so this would be indicated by writing double bar v, and then square root of 3 squared plus 4 squared. Let's work this baby out. So this is 9 plus 16, which is the root of 25, which is then 5. So this confirms that the length of our vector here is 5. If you don't have grid paper, then finding it through a calculation is usually what you do. Now, imagine the goal is to get a vector that gives you a velocity. In other words, you're going to go in the same direction, but say at 2 units of speed in that particular direction, or 3 units of speed in that particular direction, the same direction as this vector here. So here is the algorithm, so to speak. First, let's write this down. First, what you do is you find the magnitude of your vector. So find magnitude, the length of the vector. That's check in our case. We've got that already. That's good. Next, divide v, or whatever the vector is, by the magnitude. Now that we don't have, let's work that out. So now let's divide v by the magnitude. So you do that by taking the horizontal component and dividing by the magnitude. So it's not 4, but it's 4/5. Then you repeat that for the vertical component, so it's 3 over 5. We can mark these values up pretty easily so we understand what this new vector means in this position. So this is a vector. It's a unit vector in the same direction as the original vector. To understand this properly, this is what we have to do. Come over here and keep in mind that I have 4/5 and 3/5 as the components of the new unit vector. So take a look. Because I chose 1, 2, 3, 4, 5 gaps to represent a 1, I can easily mark 4/5 and 3/5 on it for that reason. So for example, I would begin over here and I would count 1, 2, 3, 4/5, and then 1, 2, 3/5 this way. Look over to this axis right here. You see, because the whole vertical spacing is from 1 to 2, and as you can see, this is 1/5, 2/5, 3/5 right here. You see? So this is 3/5. Same thing over here. Let's be clear, right? So this is 1, 2, 3, 4, which brings you up to here. You see? So this blue arrow represents our unit vector. In other words, the vector, the red vector divided by its magnitude. Now that you have a unit vector in the same direction as the red vector, what you can do next is simply multiply. I'm going to call this u here. And remember that its definition is v divided by the magnitude of v. So you take u, and you multiply u by some scalar, whatever scalar you want, for example like 2 or 3 or -10 and so on. So in our case, say I'm going to have 2u, which is really 2 times the v divided by the magnitude of v, like that, the unit vector. It always has to be the unit vector because this is logically equivalent to saying that if you want the magnitude of the new vector, this one right here, if you want the magnitude of this new quantity to be equal to 2, you need to have a 2 multiplying v over its magnitude, because that v over its magnitude is logically like the length of the vector is 1. So you end up with 2 times 1, which is 2. That's a tricky part for many people to understand. So in other words, see over here, that unit vector, to be very clear, remember this here is a length of 1. So if you're going to multiply this unit vector, you want this to be 1 and not 2 or 3 or something else, because 2 times 1 would give you 2. 10 times 1 would give you 10. 50 times 1 would give you 50, and so on. Otherwise, if you make this different from 1, you would distort the length of your new vector that you want to be along the same direction as the red one. Let's convince ourselves mathematically, though, that what I'm telling you is actually true. So what I mean by that is, take a look. I'm going to find the magnitude of this new vector, which is 2v over magnitude v. So I'm finding the length of this new vector. This is a vector quantity. Let's write this out in a little more detail. This becomes the magnitude of 2, and v divided by v is this vector, so this is 4/5 and then 3/5. Alright, awesome. And then over here distributed 2, so I'm gonna have 2 times 4, which is 8. So this is now 8/5. And then here I'm gonna have 2 times 3, which is 6. This is 6/5. Let's find the length of this vector. In other words, what we want to do is make sure that the length of this vector right here is equal to 2, because as you can see, it's a 2 in this position. Let's confirm that, not just believe it. So when I work that out, I will have 8/5 plus 6/5 using the Pythagorean Theorem as usual. And then here I will have now 64 over 25 plus 36 over 25. And check it out. So now this is 100 over 25. Okay, getting close. So this is 4, which is equal to 2. So in other words, this 2 is the same as this 2. This 2 right here. This 2 right here. I know this is a lot, right? It can be a bit overwhelming. Let's just review. So remember what our goal was. We began with the red vector, and the goal was to get a vector in the same direction as the red one, but for example, a vector whose length is 2. So the steps are, first, find the magnitude of the red vector. I did that above here. Then you take v and you divide by its magnitude. That's v over its magnitude. In this case, 4/5 and 3/5 as the components. You need that vector. This is logically equivalent to, for example, saying that 5 is really 5 times 1. Or 10 is really 10 times 1. That's the logical equivalent. Even if you think about a $100 bill, what it really means is 100 $1 bills, correct? It is a unit, a basic unit of 1. Same logic applies here. So this is like your logical unit of 1. After that, you simply take and you multiply. So it's 2 times u. In this case, it's 2 times v over its magnitude. The last calculation, to be clear on why we did that, it was 2 times v over its magnitude. In other words, 2 times u. You distribute this to the 4 and the 3. That gave 8 and 6 in the top. Then I applied the Pythagorean Theorem to this new vector, and notice that 2 came out, which is exactly what I wanted. What this confirms is the vector 8/5 and 6/5 is in the same direction as the red vector, but its length is 2. We can indicate that because we know that it's 8/5 and 6/5 simply by drawing it this way. Take a look. 8/5 and 6/5. We have everything that we need in these pictures, so let's see here. This is, let's see, this is about 8/5 and then 6/5. Where would that be? That would be about here. So that would be that vector right here. That's our new vector in whatever color that is, bisque or beige, I'm not even sure. It's another vector. So we can mark this new longer vector as the following. 2u like that. Or in other words, twice v divided by its magnitude v. That's what that is. So if I wanted that same vector to be 3 times as long, I would multiply u by 3. If I wanted that same vector to be 50 times as long as first find the u, or the unit vector, in the same direction as the red one, and then multiply by 50. Alright, so I've zoomed out here. I hope you can see all of it. I know it's quite a lot, but it's interesting stuff, and this does have actual applications, for example, in video game programming, because you're shooting things in particular directions and at particular speeds. I'll see you in another video.